Okay, let's do the 10th question. The 10th question is cot inverse root over 1 plus x plus root over 1 minus x whole divided by root over 1 plus x minus root over 1 minus x, okay, which is equal to x by 2, and x belongs to 0 to pi by 4. Now again, if you see, look at this, if this expression, if this whole expression was some cot theta, then you will have cot inverse cot theta, which is a property, that is cot inverse cot theta is equal to theta if this theta belongs to the range of cot inverse, that is 0 to pi open interval. Okay, so now let's change this or convert this to cot theta, some value of cot. Okay, now let's take the left hand side, that is cot inverse 1 plus sine x whole root plus root over 1 minus sine x whole divided by root over 1 plus sine x minus root over 1 minus sine x. Okay, now let's take the separate line, solve it. Okay, 1 plus sine x whole root plus root of 1 minus sine x whole divided by root over 1 plus sine x minus root over 1 minus sine x. Okay, now you can see that there is root or the radical in the denominator part. Okay, so we have to remove this radicals or the square roots. Okay, for that we will multiply this with its conjugates. Okay, so this will be, see, I think you all know that, see, if it's 1 by root 3, you have to remove the root from here. We multiply it with root 3 upon root 3. Okay, so we'll get root 3 by 3. So the root part of the radical is removed from the denominator part. Okay, the same way we have to do here. Again, if we, one more example, root a plus root b by root a minus root b. So to remove this, you multiply it with its conjugate, that is multiplied by root a plus root b whole divided by root a plus root b. Okay, so in the same way I have to do with this. Okay, for this also we have to remove the radicals from the denominator part, so we multiply it with its conjugates, that is root 1 plus sine x plus root 1 minus sine x whole divided by root 1 plus sine x minus root 1 minus sine x. Now this is multiplied with its conjugates, that is root 1 plus sine x. Now this is minus, here will be plus root 1 minus sine x whole divided by root 1 plus sine x plus root 1 minus sine x. Okay, now if you see, this is, if you think this is a and this is b, this is a plus b, and this is also a plus b. Okay, a plus b into a plus b will be a plus b whole square. So you can write this as root 1 plus sine x plus root 1 minus sine x whole square. Okay, a plus b into a plus b, a plus b into a plus b is a plus b whole square whole divided by, now this is in the form a minus b into multiplied a plus b, a minus b multiplied a minus b into a plus b. Okay, this is a square minus b square. So we can write this as 1 plus sine x whole root whole square minus 1 minus sine x whole root whole square. Okay, now let's expand this. Now this is in the form a plus b whole square. Let's expand this. Okay, a square plus b square plus 2ab. So 1 plus sine x whole square, that is a square plus b square 1 minus sin x whole root whole square, a square plus b square plus 2ab, 2 multiplied by 1 plus sin x ab 1 minus sin x. Okay, now here for this, the geometry, so you see the square and the root get cancelled out. Here also the square and the root get cancelled out, so you get 1 plus sin x minus 1 minus sin x. Okay, so here also you get this both cancel out, square and the root, square and the root. Okay, so you have remaining this, so let's write that. Okay, so you'll have 1 plus sin x plus 1 minus sin x plus 2. Now this can be taken in single square root. Okay, whole root 1 plus sin x into multiplied 1 minus sin x. Okay, whole divided by, now okay, this one 1 plus sin x 1 plus sin x minus 1 plus sin x. Okay, minus 1 plus sin x. Okay, now you can see that this sin x and this positive sin x and negative sin x get cancelled out. Now this is positive plus and this negative 1 get cancelled out, so the remaining will be 1 plus 1, you'll have 2 plus 2 this one. So this is again in the form a plus b into a minus b, so you can write a minus b whole square. Okay, same form, a plus b into a minus b. So this can be written as root over a square, sorry, not a square, 1 minus sine square x. Okay, whole divided by sin x plus sin x will become 2 sin x. Okay, now you know that sine square theta plus sine square x plus cos square x is equal to 1, so cos x will be root over 1 minus sine square x. Okay, same thing, root over 1 minus, we can change this to cos x, so 2 plus 2 cos x all divided by 2 sin x. Okay, which implies, now let's take 2 common, 1 plus cos x all divided by 2 sin x. Okay, this 2 and 2 get cancelled, you have 1 plus cos x all divided by sin x. Okay, now you have a formula, cos square x is equal to 1 plus cos 2x all divided by 2, or 2 cos square x is equal to 1 plus 2 cos 2x. Now if you see this one and this, if you compare this, you have x here but you have 2x here, so let's divide it by 2 on the angles, so you'll have 2 cos squared x equal to 1 plus, now this 2 and 2 get cancelled, you have cos x. Okay, now this is both identical, and again if you look at this sin x, you know there is a formula sin 2x is equal to 2 sin x cos x. Since this is sin 2x, sorry, this is sin 2x, okay, and we need sin x, so let's divide this by 2, and here 2 and here 2, this 2 and 2 get cancelled, you have sin x equal to 2 sin x by 2 cos x by 2. Okay, so now let's replace it, 1 plus cos x with 2 cos square x. Okay, so 2 cos square x not 2 cos square x, it's 2 cos square x by 2. Okay, 2 cos square x by 2, 2 and 2 get cancelled, you have 2 cos square x by 2. Okay, Yeah, 2 cos square x by 2. And here instead of sin x you can write 2 sin x by 2 cos x by 2. 2 sin x by 2 cos x by 2. Now this 2 and 2 get cancelled. Here 1 cos square, 1 cos and 1 cos here. So remaining will be cos x by 2 and sin x by 2. Now you know that sin by cos is cot. Okay, so we can write this as cot x by 2. Now we have simplified this and we have got something which is having cot. Okay, so we can replace this with cot x by 2. Okay, so we'll have cot inverse instead of this we'll write cot x by 2. Okay, now according to the property cot inverse cot inverse cot theta will be, it will be only equal to theta when this theta is in the range of the cot inverse. Okay, the same way cot inverse cot x by 2 is equal to x by 2 only if this x by 2 belongs to the range of cot inverse, that is 0 to pi. Okay, now let's find out whether it's in the range or not. So here its given condition is x belongs to 0 to pi by 4. Okay, x belongs to 0 to pi by 4. We can write this as x less than pi by 4, not because this is open interval, only less than. Okay, is greater than 0. Now we need to check x by 2. So let's divide by 2. Here 2 and here also 2, here also 2. So this will be 0 less than x by 2, which is less than 2 becomes multiplied with 4, it becomes pi by 8. Okay, so this can be written as x by 2 belongs to range 0 to pi by 8. Okay, now according to the unit circle, the range of cot inverse is from 0 to pi. This is the range. Okay, this is the area where cos inverse exists. So now this is pi by 8. Pi by 8 is somewhere here. Okay, pi by 4, pi by 8 is here. Okay, this is inside the range of the cot inverse. So we can say that x by 2 belongs to the range of cos inverse. Okay, or this is a subset of this range. Pi by 8 is a subset of this 0 to pi. Or x by 2 belongs to 0 to pi by 8, which is a subset, which is also a subset of 0 to pi. So we have proved that, therefore we can say that cot inverse cot x by 2 equal to x by 2. Okay, because this is in the range, and this is what we have to prove, that is x by 2. We have got x by 2, so this is the right hand side. Okay, that's it.